Okay, make sure you get whiteboards today. And please conserve ink. Alright, don't make art projects. We are limited and we're going to use these a lot from here out, okay? So if you will get out your assignment from yesterday, we started 7-3 and we did the first page. Those who were absent, you will have to make up the first page. The video is out there. It's been out there since yesterday. Okay. Afternoon, like midday. So today I'll be recording this class. So this actual lesson will be out there. I'm going to pause the video right now to do attendance, but you have about 3 minutes to go over this, take some notes, and then I'm going to start the lesson. Okay, so a logarithmic function is just the inverse of an exponent. So if I ask you to graph an exponent, we know that it's going to have an asymptote, right? And if I have something, they've shown y equals 10 to the x power here in red, and it's going to be an asymptote to the x-axis, right? It's never going to cross the x-axis. It's never going to touch the x-axis. So when you talk about the range of this, it's going to be all values greater than 0, right? Because it's never going to hit that y equals 0. It's going to be above that axis. So it's going to grow and get larger and larger and larger. So if I was to do that y equals x line, if everybody would flip their whiteboards over on the back where the grid is, and just graph y equals x. Just graph y equals x. So, let's see if I can get a graph up here. All right? So when x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. Whoops. Right there. When x is 4, y is 4. And when x is -1, y is -1. -2, -2, -3, -3, -4, -4. All right, and so on and so forth. When we do a line through this, that is the graph of y equals x, right? Because whatever you input for x, that's going to be y. Okay, any questions about that? Now draw that graph that I just showed you here. This y equals 10 to the x power right here. It looks like it's going to, my y-intercept is 0, 1, so draw that. And it looks like it goes through, it's almost touching the y-axis before it gets, the x-axis, before it gets to the first -1 unit. And it goes on out. And then, so when you have 10 to the first power, what do you get? You're going to input 1, you're going to get an output of 10. So that first point is going to be way up here. So it's going to shoot off like that, up there, okay? So if we look again, let's talk about domain and range. Domain is what are all the x values? Well, for an x value, I could draw a line anywhere through this because you know this goes on forever and ever. And it's going to touch eventually everything out to infinity. So my domain can be all values. But my range are all my x values. My range are my y values. So what is my range here? If I could plot out, let's do this here. If I could draw this out, where is it going to touch y values? Well, does it really ever hit the 0? Because it's an asymptote, it's never going to hit the 0, y equals 0, so it's going to be everything greater than 0. So for your range, you're going to say y is greater than 0, not greater than or equal to, because it never touches that x-axis. It's greater than. So there's your domain and range. Now, what if we were to do a mirror image of this over that line, y equals x, our reflection line? So if you were to plot these over here, so this point here becomes what when we fold it over?
1, 0.
So if we reverse them, if that's 0, 1, it's going to be 1, 0. Now, keep reflecting all these points, okay? So I'm going to pick this one here. That yours may not be close to this, but I've got about almost 1 and 5, so that means at 5 it's going to be almost 1. And then pick some other points and reflect them. So at about -2, 0, it should be 0, almost -2, not quite. So if I have these, I can go ahead and reflect this. So that's pretty close to, I mean, not perfect, but we're freehanding, right? There's a reflection. And if you use your imagination, what shape could you make this into? I always think of a butterfly. Right? There's its little body and its antenna, right? Looks like a little butterfly. That's what it reminds me of. But if you graph these, this is what you get. So this is your exponential function on top, and this is your logarithmic function, the inverse of that on the bottom. So if they ask us to graph a log, we can just turn it into the exponential form, graph that, and then invert it, right? So that's where we're headed with this. Any questions? All right, so let me read the rest of this. This is a logarithmic function is the inverse of an exponential function. The graph shows y equals 10 to the x, and it's inverse. So the inverse of that becomes y equals log x. So there's your two things that you need to know. Y equals 10 to the x, and y equals log x. Note that 0, 1, and 1, 10 are on the graph of y equals 10 to the x power, and that 1, 0, 10, 1 are on the graph of y equals log x because they're inverted, right? You switch the x and the y values. Recall that the graphs of inverse functions are reflections of each other across the line of y equals x. You can graph y equals log base b of x as the inverse of y equals b to the x power. So that's the important facts about what we're doing today. So make sure you've got your 7-3 in front of you. And actually, before I move on to the first lesson, I want to go over something we did yesterday. And I ask you to work a quiz, the standardized test prep on 7-2. And I ask you to work problems 1 and 2. Okay, so on the first one of those, and I'm going to go over it because it was a little different. There are tricks to solving it to make it quicker, but the way they expected you to do that was just to make a table and start checking all your values till you have one that matches. Because they told you, suppose you deposit $6,000 in a savings account. So there's your principal, $6,000. And actually, let me go back and put my formula up there. We know that it's A, capital A of t, so my amount over time is equal to the principal times e to the r times t. So we've got our principal 6,000, right? Because they said it. You deposit 6,000 in a savings account, so that initial amount becomes your principal. It pays interest at an annual interest rate of 4%. So my R is equal to 4%. It's compounded continuously, so that means we're going to be using that formula. How many years will it take for the balance in your savings account? So time is what we don't know. Okay. They want our final amount, which is that A of t, that final amount, to equal $8,000. Round up to the nearest dollar. Okay, so when it says round your answer up to the nearest, oh, not dollar, nearest number of years, because we're talking about time. So even if it was 2.1, you're still going to round that up to 3, because it tells you no matter what your answer is, round up to the nearest full year. Okay? That's not the answer. I'm just giving an example there. All right, so what do we have here? We've got our final amount, A of t, is 8,000. And that's going to be equal to our principal, which is 6,000, times e to the r times t. So our rate, and here's one of the biggest mistakes I saw. You guys just put a 4t there. Well, that's not correct. It's 4%. You've got to turn that to a decimal number. So 4%, convert that to a decimal number, and what do you have? You have to move your decimals here right now. So you have to move it back 2 places. 1, 2. So there's your new decimal. So it's 0.04 times t. Okay? So that's 0.04 times t. All right, so let me blow this up down here. So we've got 8,000 equals 6,000 times e to the 0.04 t. So the first thing you want to do is, you can clear this, right? Divide each side by 6,000, and then the zeros cancel out, and then you can simplify this to 4/3. So you can come up with, and 4/3 is just 1.33 equals e to the 0.04 t. Now, if you were going to solve this the algebra 2 way, you would do this on each side, which cancels this out. Okay, now pull up your yellow calculator. When we do that, ln of 133 equals, so this happens, 0.04 t. I always go sideways. I must have balance problems. Okay? So when we do this, I want you to look for the LN button on your calculator. Do you see it? It's 2 under your green second button. So type that button and type 1.33 and press enter. And you get this huge number like, let me scroll this down. It's going to be 0.285178942. Okay, now let me show you something here. Now let's clear this, well, equal 0.04t. I'll straighten it out a little. Okay, now I can divide each side by 0.04. So now take that answer and divide by 0.04. And you should get, that cancels out, your answer. 7.1294, blah, 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 but they said round up. So our time is going to be equal to 8 years. Okay? So that is the short and easy way. Now the way that we did in the book, at the very beginning of the book, we made a table for the exponents and we just started graphing for t. So when I input 1 for t and you solve this initial equation, before I started simplifying, I guess you could take it, the 4/3 equal e to the 0.04t. You could have done that because they told us. Suppose you deposit $6,000 in a savings account that pays interest in an annual rate of 4% compounded continuously. How many years will it take for the balance of your savings account to reach $8,000? So that's why I said the final amount you want is $8,000. Our unknown is t. Okay? So remember that capital A of t is your final amount over a period of time. And they said, how long will it take to reach 8,000? So 8,000 becomes my capital A of t. Right? So what you would have done, you could have gone ahead and switched this to 4/3 equal e to the 0.04t. And you, at this point, what the book expected you to do, because it was the first problem here on the quiz, you would have made a chart for t, right, and your A of t. And you would have plugged in 1, 2, 3, 4, 5, 6, and by the time you got to 7, you know, you were below 8,000. When you get to 8, you're above 8,000. So you would have picked 7 and rounded up to 8. Question?
How'd you get 0.4?
Because that's your interest rate. They said the rate is 4%. So the question was, how did you get 0.04? Because your rate here is 4%, and you have to convert that to a decimal number. So 4% is 0.04. Okay, so that's how you did number 1. So you could have taken it the easy, shorter way, or you could have, like what they expected you to do, was make a table and calculate all those values. So what I didn't work through this before I gave the quiz. I just glanced at it and just thought they were the simple ones, like number 2 that I'm going to work here. And when I started working out, I'm like, no wonder so many people looked like they were just lost when they were working it. And so I apologize for that. I usually work out everything I give you, and I just thought this was a quick way to reinforce, and it was just one of those times that they throw something in there that I didn't expect. Okay, any questions on that? All right, let's look at number 2. Now this was the one I was hoping for. Let's start with our formula first. So we know it's A, capital A of t, hopefully you're memorizing this by now, equals your principal times e to the RT. All right, so now they say, suppose you make $1,500 at your summer job and you decide to invest this money in a savings account. Okay, there's your principal. $1,500. You're going to start with $1,500. It's going to pay an annual interest rate at 5.5%. So R equal 5.5%. Okay? Don't change a thing yet. Okay? 5.5, and you must have the percent sign. Okay? Because your R is not 5.5. We've got to convert that to decimal. Okay? And we'll do it in a minute. Compounded continuously, that means we're going to use that compound interest formula. How many dollars will be in the account after 5 years? There we go. T equal 5. All right, 5 years. So now we're going to write our equation. Our A amount after 5 years is equal to our principal, which is 1,500, times E to the rate, which we're going to convert now. So 5.5, we got to move the decimal 2 places to the left. 1, 2. All right, so it's our new decimal is going to be there, so we have to add a 0. So our new converted amount is 0.55. 0.055 times T, which is what? 5 years. And I'll use a different color to make that stand out because it's a lot of 5s. Okay, so what's the first thing we want to do? We probably want to calculate that 0.055 times 5. So let's do that. Everybody do this on your yellow calculator. Go. 0.055 times 5. And what do you get? 0.275. Or 0. I never put that leading 0 there. But it's not wrong if you put it. All right? 0.275. So we've got that one calculated. Now, why don't you do e to the 0.275? So clear, pressure e to the x, which is second function, ln, and type 0.275, enter. And this is going to be 1.316530675. Now take that amount and just times 1,500. Okay, just a minute, and I'll come back to it. So you should now be at 1974, and this is money, so we need to round to 2 decimal places. So I'll go ahead and write a few, 796012. Because we're talking about money, let's see, what did they ask us? Oh, round your answer to the nearest whole dollar. Okay, so we're just 0.79 is going to round up to 1975. So we're going to round this 4 up to the nearest whole dollar. So your answer is 1975. A lot of people got this one right because it was straightforward, and that's what I thought both of them were. Okay, so I apologize on, I think everybody could have got it if I had given you more time, but that's why I'm not counting that as a quiz grade, but this is on your test. Okay, so the second problem is on your test for sure. All right, now someone asked me how did I get this 1.316530675. Okay, so let's, and guys, we're into today's lesson, so I got to go pretty fast here. All right, so did you calculate 0.055 times 5? Did you do that?
Oh yeah, I got 0.275.
Okay, now type e to the 0.275. E to the point. So press your second function, the green button. See the e to the x to underneath it?
Okay.
Type that, and it should say e and a box flashing. Type 0.275 and press enter. Did you get it?
Yeah.
Okay, very good. Now multiply that answer times 1,500. I'm waiting. Okay, so what'd you get? Okay, and it says round to the nearest whole dollar, so round up. Because it was 79 cents, we're going to round up to 1975, okay? Any other questions on those? Okay, that second one, the one we just worked, is on your test. Please put the drinks away, okay? No food or drink in this room. All right, let's move on to today's lesson then. So yesterday we did the first side of 7.3 and we learned about logarithms, and then we reviewed that this morning when we began our lesson. And then we talk about the graph now. The second page is more about graphing and translations. So that's what we're going to wrap up our lesson on today. And we're going to turn this in before you walk out of here. So stay with us and don't doze off because I don't have time to slow down. All right? So we learned that this highlighted in yellow part of the graph is our exponential our exponential graph. Okay, and underneath here, that's the inverse of that. So that would be our logarithmic function. Okay, so let's look at, let me clear some of this up. I drew a butterfly last year. They always remind me of butterflies. Okay, problem 4 says graphing a logarithmic function. What is the graph of y equals log base 3 of x? I scribbled out describe the domain and range and identify the y-intercept and the asymptote. But I did circle asymptote. I want you to really pay close attention. I've talked till I'm blue in the face about y-intercepts, domain, and range. So let's focus on the asymptote. Okay, so when we graph this, the first thing we want to do is translate y equals log base 3 of x. And we want to switch that over to an exponential function. And we learned that yesterday. So y equals log base 3 of x equals, it translates to y equals 3 to the x power. Right? Because we want to say 3 to the x power equals what? So let's do this. Your step 1 is we want to graph y equal, whoops, wrong pen, y equals 3 to the x power. We want to graph this. So when you graph it, you're going to get this guy. Okay? And it doesn't take long at all to graph that because it's going to flow off the page pretty quickly. So just get your main numbers. Do your zeros, your ones, your twos. So we know 3 to the 0 power is 1. So when we input a 0, we're going to get 1. So all of these are going to go through 0, 1, right? And then, and notice that this graph is in units of 3. So you would think that 0, 1 would be on a perfect crosshair, but because it's all units of 3, it's not, right? So the 0, 1 is right there. And then when you do 3 squared, so input a 2, and you're going to get an output of 9. 3 squared is 9. So you're going to go over 2, up 9, and you get your second point right there. Right there. Okay. First point is, well, actually on the other side. Let me move that. It's right there. It's 0, 1. Second point's there. And your next one, you're going to have input 3 for x. Well, 3 cubed, 3 times 3 is 9. 9 times 3 is 27. So you're off the charts. But because they used units of 3, they were able to graph it right there. So input 3, output 27. So now we've got enough to graph this. And remember the x-axis is your asymptote. So it's going to come through here and do this. Now you want to take these key points and inverse them and graph it across that line of symmetry there. Okay.
How did you get 2 and 9? 2 plus 2, 9, and 2 cubes.
Because you've got y equals 3 to the x power. And when x equals 2, 3 squared is 9. Okay? That's all right. So remember, this whole chapter is about your powers being the unknown values, exponential functions. All right? So now you just want to choose a few points along your y equals 3 to the x power, the one that's really easy to graph, and just transpose it, reverse their coordinates, and graph it below. Okay? And that's how you get your log, y equals log 3 of x. And that's all there is to it. So I said let's focus on the asymptote. So what axis does it not touch?
Oh, it doesn't touch the x-axis.
Yeah, it never touches the x-axis, even though my graph here sort of hoses all that up. But if you look, it never touches this x-axis. Okay, so x is your asymptote. It does cross the y-axis. We will learn later on, sometimes y will be, and sometimes our asymptote will move to a number, like x equal 5. But for now, it's just the whole x-axis. All right? So we call that a vertical asymptote. The vertical asymptote is x equals 0. Okay? All right, so look at number 11 on your paper. It says a student drew the graph below to represent the function y equals log base 4 of x. What mistake did the student make when she drew her graph? If that's her log, and that's the graph of her log, what mistake did she make there? Think about what we just did to graph that. What was our first step?
Inputting the decimal for x, or inputting the exponent for x.
Convert it to exponent form,
Yeah.
exponential form, and then you graph that. Okay.
Convert it to exponential.
So, hold on, Gabe. You've got to hold off now because I got to let other people answer questions, okay? So step 1 was to convert it to exponential form. Okay, 2 was to graph that. And step 3 was what? What did we do after we graphed the first one? Not Gabe. Somebody else. What did we do after we graphed the first one? What? We say it one more time? But after we put it into the graph, what did we do next? We took we flipped it. And we flipped it over our y equals x. So we took the inverse. Okay, so what is she missing here? There you go. That's your answer. She didn't reflect it across the y equals x. Okay. So step 1, convert to exponential form, graph it, and then reflect it across y equals x. That's your inverse. All right, it says what mistake did she make? She didn't reflect it. So she just graphed y equals 4 to the x power there, and then she forgot to reflect it. Number 12 says graph the logarithmic function. So y equals log 2 of x. So what are you going to do first? You're going to make a table of values. Yes, I've got it written right here. So y equals log 2 of x. Just think of it this way. When this log goes away, this goes up. So it's sort of like, let's see if I can do this. Okay. No, I'm not going to do it. So work that while I'm fiddling with this. Okay, so when you get rid of this, this sort of just shoots up there. All right, that's how I see it when I translate them, right? So we have y equals log of 2x. So that goes away, and that moves up. Okay, so it becomes y equals 2 to the x power. So now pick your few points and graph that quickly. So 2 to the 0 power is what?
1.
Guys, don't copy off this. You should be working this. If you're copying, you're not going to learn a thing. I've got this if you're absolutely stuck, but I just see people going up, down, and just copying. Don't do that. All right, so put your x and y values there, 0, 1, 2. So x to the 0 power is, or 2 to the 0 power is 1. 2 to the first power is what? 2, and 2 to 2 squared is? So graph those 3 points. So 0, 1, 1, 2, and 2, 4. Now, graph that. And it's going to do something like that. Now reflect those. And you're done. That's how easy it is. So if you want to do 2 to the negative 1, it's going to be 1/2. So it's going to be about right there. Right. And then it's going to get smaller and smaller. So reflect all those points and then you're done. Okay. I'm going to go ahead and move on because we've got to finish here. Just like all the other functions, you've got an a value here. An a value in front of your log base b gives you your shrink or your stretch or your shrink. Okay, so if it's greater than 1, it's a stretch. If it's less than 1, it's a shrink. Between 0 and 1, I should say. Now, if it's less than 1, like if the negative sign's there, it's going to be a reflection on your x-axis. So that can get sort of crazy, right? So just realize the a value does all the same things it does in all the others. Okay. Now, the h and k is pretty close to all the others too. It's going to be a log base b, open paren, x minus h plus k. All right, so h is your horizontal translation, k is your vertical translation, and a does your shrink, stretch, or rotate, or reflect, excuse me. So there they are all together. Now, look at 14, 15, 16. Is 14 a stretch, a shrink, translation? Let's see, what does it say? Identify as a compression, a stretch, or a transformation. So what is 14? A stretch. How about 15? And 16? Compression. So there you go, those are done. Now, on 17 and 18, rewrite the equation. So it says stretch by a factor of 3 and translate 6 units up. So they give us y equal log 5x, and it says stretch by a factor of 3 and translate 6 units up. So where's the 3 going to go? The a value. So 3 log 5, and then open paren x. So it says translate 6 units up. So do I have a horizontal? No. So plus, if it's moving upward 6, so it's going to be my k value. So I have nothing for my h value plus k, which is my 6. Everybody see that? Okay, now do the last one. And remember, to reflect, what do we do? How would I reflect this one if I was reflecting it? Where would the negative sign go? In front of the 3. But we're not reflecting that one, so leave that one alone. Do 18, and then we're done. Okay. I told you we'd get through it. I had to push a little, but that wasn't bad. So how would you graph these on a test? While you're finishing that one, I'll just talk through this. It says, how does the graph of y equals log 4 of x minus 3 plus 4 compared to the graph of the parent function? Well, you want to just graph the y equals 4x, 4 to the x power. Graph that, reflect it. And then there's no stretch or compression. So all you're going to do is take that flip and move it to the right 3. I need your assignment. And up 4. To the right 3 and up 4. So that's all you do to graph these. Okay? And basically, guys, I've shown you everything out of this lesson. Hopefully that was nice and easy for you. And tomorrow we're going to have a quiz over the first 3 lessons. Thank you. All right. Any questions? All right. This concludes our lesson, and thank you for watching.